Okay, we've made it to logistic regression. The math behind this is like calculus kind of things. And, there's a lot to this that we won't necessarily get into. A lot of it has to do with logarithms and that kind of thing. But I'm going to teach you how you can do this practically. And so what we do is we get continuous data. I'm going to show you how to do a simple logistic regression. You can also do multiple logistic regression. It's just like multiple regression, but you have your variables. These all need to be continuous, and it's got to predict a nominal variable with only two parts to it. So you're looking to see if a predictor variable predicts whether or not you're this or this. So for example, I just conducted a study, and it was actually just published this month. And if y'all only knew the hours it took to figure out how to do this. Like, I didn't learn how to do this when I was getting my doctorate degree, or maybe I did, but I really didn't understand what I was doing. But little did I know that as I was figuring this out, God was preparing me to come here to Lipscomb. And so this was hours and hours and hours of figuring this out. And I'm going to share with you what I found, okay? So just overall, so you get like what I was doing, I was looking to see if like these attitudes towards school, if you have good academic self-perception, what you like, if you value the task that you're doing and motivation, do these things predict whether you're an achiever or an underachiever? And so I found, this is a multiple logistic regression, that within this model there was one thing that differentiated that, and that was motivation. Okay, that is the thing that differentiated underachievers from achievers. That's a pretty statistically significant level. And this is the odds ratio, and this is saying that if you have low motivation, you are 4.61 times more likely to be an underachiever than an achiever. That's what this means. Now, you can only interpret that way if this number is above a 1. If it's less than a 1, you can't necessarily say that. Okay, so, and I also found in a hierarchical, or kind of a version of stepwise logistic regression, I was building a model here. This was what's most interesting and significant about this study. We won an international award for this, by the way. We found that fixed mindsets, like if you believe your intelligence doesn't change, that predicted whether or not you're an achiever or an underachiever. It predicted that you would be an underachiever. Okay, and so then when I added the perfectionism in the model as well, perfectionism didn't necessarily predict whether you're an achiever or an underachiever, except for the component of organization. So the underachievers had lower organization. So we have two things in this model. Organization and fixed mindset beliefs in this second model predicted whether or not you're an achiever or an underachiever. So that's how this big picture works. So now let's do this in JMP. Alrighty. So make sure you can see this before I spend a ton of time talking to nothing. All right, here we go. We want to see if you could refer to the office over and over again, if that's associated with the type of ISS or OSS you get, in-school suspension or out-of-school suspension. Did you know that I was suspended from school in 6th grade? I did something that just was really bad, and it just changed my life. I was so shamed for it. It was just awful, and it threw me into this tailspin of perfectionism, and little did I know that it would create a career in research where I studied perfectionism. But that's my experience with personal experience with referrals and OSS. Anyways, you got to be careful. If you're a principal or a leader and you suspend a sweet girl A sixth grade girl from school. You may be affecting her whole life. Okay, so what do we do here? We've got type, and we're going to see if referrals predict type. We're going to click run. All right, so what we have here is this little S. And if you'll notice that sometimes you can click on these dots and it tells you which person it is, but it's not doing that. But it tells you that the more referrals you get, this side is OSS and this side is ISS. Now, how do I know that? I just was told that by Dr. Weimers, that if it's on here in the bottom, ISS, that's this side of things. So these are the kids. These are the people that got ISS. These are the people over here that got OSS, looking right here. So this person at row 48, I could look up who that person is. They had in-school suspension and they had about 8 referrals. Okay, that's what that's saying. Now, another thing I could do, I could click on like this number here and click add and click OK, and it's going to create a line. Then I'm going to click on this little midway point, click add, and make a line. And it's another way I can examine this data. Again, I could look at this person right here. I know her name is Melissa because I looked at it just a minute ago, and this is the 3rd time I've made this video. And this is Melissa here, and she has ISS, but she's the only one in this, no. Yes, she has ISS, and she has probably about 8 referrals. All right, so this helps you kind of see how it's broken up. Like this person right here had OSS and had how many referrals? Probably about 7 referrals right here. Okay, so way to look at it. All right, now what does this mean? Can we predict if you have in-school suspension or out-of-school suspension based on this logistic regression model? All right, what do you look at? You're going to look at this overall model here, I think. Let me just make sure I don't want to have to do this again. Okay, this whole model test, this is the chi-square, and this is called the model chi-square. You're going to literally write the word model chi-square is like a little curvy X, and this is what it equals. All right, there's 1 degree of freedom, and this is all kind of written up for you on your quick guide, what you look at. All right, now you look down here, and you're going to see this estimate. Now listen, in logistic regression, this is not called beta. This is called the logistic regression coefficient. It's just the logistic regression coefficient, and it's not a little b, it's a capital B in italics. Can you be more confusing? Okay, so it's a capital B in italics, and that's what you report. We know that this is negative. So what does this mean? So this is the order here. It says ISS versus OSS. This means that the more as referrals go up, the less likely, because it's negative, you are to get ISS. Okay? Now, if this was a positive number, if that were positive, it would mean as your referrals go up, the more likely you are to have ISS. And I know that it's statistically significant, and I'm not paying attention to intercept right now. I'm only looking at this. I really never look at intercept, okay? Now, you would report this chi-square. This one is a little different than the one up there. This is also called Wald's chi-square. So this is the Wald statistic. So you report this as well. So when it says Wald, that's this number right here. And I know that because I could actually run a Wald's test, and it shows me the same number right there, see? So that's the Wald chi-square as well. You need to report that number. Now, none of that really makes a lot of sense. Well, this part kind of makes some sense, but I like to look at these odds ratios, and this is what you would need to publish. And so it says the odds ratio is a 0.48. Now I hate it that in this example that that's less than 1, because it's a lot harder to interpret. But what you need to do is pull out your Hatcher book and look at page 331 to know how to interpret this. If that odds ratio was a 1, that would mean that, you know what, hey, it's kind of 50-50. It's 50-50 that you would have ISS or OSS. It doesn't really do a good job predicting which one you're going to be. If it's greater than 3, then that's pretty strong. It's a strong positive relationship. If it's less than 0.33, it's a strong negative relationship. So, you know, if it's a 1, there's no relationship at all. So how would we interpret this? Okay, since it's like, if it were below a -33, it would really say the more referrals you get, it's a lot less likely you would have ISS. We kind of talked about that before. But if this number was bigger than a 1, then we're able to say some neat things like if it were 3 point something, then you're able to say, as your number of referrals go up, you're 3.12 times more likely to be classified as getting in-school suspension or whatever. Okay, but it's this example a little tricky, and I'm using this from my Hatcher book. If you're really doing logistic regression, you really need to kind of study up on this. Now, what else do we report? You look at the effect size, but it is not the same thing as our typical R-squared. This is called McFadden's rho. It took me a long time to figure this out, like with hand calculations, what this is doing. In a nutshell, you cannot interpret this like you do R-squared, that percent of variance is accounted for. That's not how you do it. You just say scores between 0.20 and 0.40 are considered an excellent fit, and so that is considered an excellent fit. This is a good model to go by. Now, there's one more thing that I would encourage you to look at, and that is called the confusion matrix, and it's kind of confusing to me. What? All right, so what do we do? What do we do? We click on the confusion matrix, and this is not that hard. I just have to think about it, and I don't think JMP does a good job labeling things here, but here we go. This is showing that, okay, I've had 25 people, and this model said, okay, of the 25 people, this model classified 20 of them correctly, that it predicted that these kids who had ISS actually had ISS, so it correctly predicted that. But this model said, but 5 kids we actually predicted would have OSS. But that wasn't necessarily right. Okay, so these two numbers are what we're looking for to be the actual ones. These are predicted this way. That's why this is confusing to me. And so then right here, this is saying that for the OSS, it correctly said, okay, of the OSS, it correctly said 20 of them were correctly classified as OSS, but 5 of them were classified as ISS. Oops. All right, so how correct is this model? Well, it so happens in this example, it's, I'm just doing the math in my head super quickly, like 5 out of 25, I mean 20 out of 25, that's, what is that? I'm so tired. Is that 25%? Hang on a second. No, 75%. Hang on. Let me get out my calculator. Okay, Sorry, I don't want to have to remake this video. But so what I do, I say, okay, 25 people, and then I divide it by 20 that were correctly classified. No. 20 out of 25 people were correctly classified. So that's 80%. 80% were correctly classified as to go to ISS. And it would have been the same for OSS because it's the same numbers here. So 80% of those going to OSS were correctly classified. And that's how you do the confusion matrix. Now, if you write this up, you are like so there, y'all. Make sure you can see what I am doing. I'm so excited that this is probably the last video. All right, so this is an example of how you would write this up. Okay, this part right here, you could literally copy and paste what I have and maybe put some of that in your real words. But I'm just reporting what that R squared value was, even though it's not really R squared. It's called the McFadden's rho. All right, I reported that walled statistic that I showed you. Well, what in the world is this capital B in italics? Remember, that is the logistic regression coefficient. All right, so that's how you would write it up. And I have an example of how you might want to set up these tables if you are doing logistic regression. And I'll just show you this. You know, sometimes you'll read something about a constant. What is that? That is the intercept. That's what I keep saying. Don't worry about reporting. Sometimes publishers want you to report it. Sometimes they don't. Usually not. But I think in Hatcher, it gives examples where the constant is reported, but that is just the line where it shows the intercept. That's all that is. All right, so good luck. I'm proud of you guys. You have made it. Congratulations, and I'll see you later.